Hi there, in this lesson we're going to look at the area of a rhombus and also the area of a kite. Now before we get into that, it's important to look at the word diagonal. Now the word diagonal in maths springs up ideas of a diagonal line usually. And a diagonal line, most people look at this idea here, a diagonal line, sort of this slanty line from bottom corner to top right. It can go the other way as well, but generally speaking that's what people think of as a diagonal line. So if I asked you to draw a diagonal line inside this shape here, which is a rectangle, you probably would go like that from the bottom corner to the top right, or the top here to the bottom corner. However, this is also a diagonal line inside, but it tends to be people go from corner point to corner point, which is actually accurate and correct. A diagonal inside a shape should go from a corner point to another corner point. However, when you look at a rhombus and a kite, you can see that if I'm going from a corner point to a corner point, I either need to go from this corner to this corner, because if I do that, that's just along the side of it, or this to this, and that's what a diagonal is inside a rhombus or a kite. It's from a corner point to a corner point, and a kite, you could have it like that as well, but again, across like that would be okay, and up and down like that would be okay. So actually the definition that you probably take down. In geometry, a diagonal is a line joining two corners of a shape. Corners not on the same edge, because if you joined the corners on the same edge here, you would get a line along the perimeter of the shape. Informally, any sloping line is called diagonal, but that's what we're going to refer to as diagonals from now on. Right, so let's look at the rhombus first. So a rhombus is basically a fancy name for a diamond shape. So if I was to draw it, I would create a rectangle first to draw a perfect rhombus. You don't need to draw a rectangle first, but if I go halfway in, put a wee dot up here, halfway in, put a dot down there, halfway up, put a dot there, halfway up and put a dot there. I'm going to create a diamond shape, which is a rhombus like that. Now what you'll notice is that the rhombus is symmetrical. There's a line of symmetry right down the middle here, and there's also one right across here. So it's a very symmetrical shape. And all the side lengths are the same size here. Right, so if I wanted to work out the area of this shape, the easiest way is to compare it to the surrounding rectangle and think what fraction of the surrounding green rectangle is it. Now, if I take it here and I move it around like that and shove it over, and I think actually what I'll do is I'll put that one up there. So if I take that there and put it there, you can probably see what's going to happen here. And if I take that one, that needs to spin round actually, like that, and spin it around there. You can see that I've actually covered half the shape. So the rhombus is actually half the surrounding rectangle, which is very similar to what we said with a triangle. So you can see if I put it back there, it's just half of the surrounding rectangle. So the formula for a rhombus is basically, it's kind of like length times breadth divided by 2, but we don't use that for a rhombus, we use diagonals. So diagonal and another diagonal. Now, because there's two diagonals instead of length and breadth, we usually use a capital D for one of the diagonals and a small case d for the other one. Again, it doesn't matter too much which way around you go there. And we're timesing it by a half instead of dividing by 2. But if we look at an example, you could do that. You could do it as a diagonal times diagonal divided by 2. But we tend to do this a half d times d, and that's what you'll see in the textbooks. So this is the idea here. Let's have a look at it. So to work out the area of this, the diagonal can either be inside the rhombus across the middle or sitting the outside. It doesn't really matter where you have it. So if it's from the outside, just use it as a diagonal. So 8 times 3 divided by 2, or 3 times 8 divided by 2. You can do the 3 times 8, which is 24, and half it, and get your 12 centimetres squared, or the same as before if you watched the earlier lessons, half the 8 and get 4 times 3. This is the way I'd probably like you to set it out. So area is a half d times d. Now the diagonals 4 and 7, so it's a half times 4 times 7. So you can do 4 sevens are 28 and half it and get 14, or half the 4 and get 2 and do 2 times 7 and get 14. Okay, right, well, let's have a quick look at a kite as well. So the difference with a kite, I'm going to go halfway up when I'm drawing it here and halfway up again, but I'm not going to go to the middle here because a kite's not symmetrical about both sides, if you like. So I'm going to kind of just go up one either side and then join my shape up, if you like, my dots. So I've got there, there, there. So it's very similar to a rhombus, except what you notice is one side is longer than the other side. And it didn't need to be there. I could put the yellow dots there and create a shorter front bit and a longer back bit. But that's the idea of a kite shape. Again, if I'm trying to work out the area, I need to work out what fraction it is of the surrounding green bit. And again, what I can do is I can think about taking bits apart and trying to rearrange it. So what I'm going to do is I'm going to flip that left and right, and I'm going to put it up here. And again, hopefully you can see what's going to happen. And I'm going to do the same with this. I'm going to flip it left and right and put it up here. And you can actually see it's exactly the same. It's a half of the surrounding rectangle. So it's quite handy this, that the formula for a kite is exactly the same as a rhombus. It's a half d times d. Now you'll notice the brackets in here, they don't really matter. You don't need to put brackets in, but you can if you want. Right, let's look at a few examples, because it's exactly the same. Again, I probably prefer this format here, but you could write it as d times d divided by 2. So if the diagonals are 4 and 9, remember they can be outside the shape or across the inside. That would be 9 there as well. So 4 times 9 divided by 2, that would be 36 divided by 2, which would give you 18 centimetres squared. Remember your units. Or you could half the 2 and do 2 times 9, which is 18. And to finish off, we've got two diagonals here, 3 and 6. So you're doing a half times 3 times 6. 3 sixes are 18, half it you're going to get 9. Again, remember your units, metres squared, we're talking about area. Or you could half the 6 and do 3 times 3, and that would give you your answer. So the diagonals are across the middle of the shape from corner point to corner point, and the rhombus and the kite, handily enough, have the same formula for the area. Please remember to put the correct units in. It's always metres squared or centimetres squared or millimetres squared.